everyone, thank you so much for clicking onto the video. Today we're going to be looking at precipitation reactions. So we're going to look at the reactions including ionic equations and the accompanying colour changes of aqueous copper 2+, iron 2+, iron 3+, manganate 2+, and chromium 3+, with aqueous sodium hydroxide and aqueous ammonia, and that's including precipitation reactions and complex formation with excess aqueous sodium hydroxide and aqueous ammonia. Now we're going to look at metal aqua ion reactions with sodium hydroxide. So first looking at Fe2+, when we add some sodium hydroxide, the two OH- ions take away two H pluses from two of the water ligands, which are coordinately bonded to the iron 2+ ion. And so what we form is a green precipitate from a green solution, and two waters are formed. And this kind of reaction is a hydrolysis reaction. And this is the case for all of these reactions. So they all go through hydrolysis. And so this can also be called precipitation reaction because we're also forming a precipitate. When we add excess sodium hydroxide, there is no visible reaction. And it's a similar reaction with copper 2+. So the same thing happens. Two hydroxides are reacted with it, and so two H pluses are taken from two waters which are bonded to this copper 2+ ion, and so a blue precipitate forms, and two waters are also formed. One thing to note is that precipitates are formed because the complexes which are formed are neutral. So we have copper here with a charge of +2, and these OH minuses are -1 each, and so they balance out. And so if you ever forget how many hydroxides it's reacting with, just remember that the precipitate which is formed has to be neutral, and so the number of hydroxides needed has to balance out the charge of the metal. And again, when we add excess sodium hydroxide, there is no visible reaction. When we look at iron 3+, something slightly different happens, and that's because it's a 3+ ion. So this time we're reacting with 3 hydroxide ions, and so precipitate forms again because it forms a neutral complex. So this time it's taking away 3 H pluses from 3 of the water ligands, and so this forms 3 waters. And so again, hydrolysis occurs. So we form brown precipitate from an orange solution. And again, when we add excess sodium hydroxide, there is no visible reaction. Now on to chromium 3+. So with chromium 3+, the same thing happens as the Fe3+. So when we add sodium hydroxide, we react it with 3 OH minuses, and it forms a green precipitate from a violet/dark green solution. And also 3 waters are formed. And then this is what's different, is that when we add excess sodium hydroxide, this green precipitate then reacts with more of the hydroxide ions, and so a dark green solution is reformed, and we have a 3- ion. It's a solution because it's charged, so it's no longer a precipitate. And so more hydrolysis occurs. So these 3 OH minuses have taken away 3 H pluses from 3 of the water ligands, coordinately bonded to the chromium 3+ ion. And so we have 6 OH- ligands now attached to this chromium 3+. And so that's why the charge is 3-. And of course, the 3 waters are formed. And then the fifth metal aqua ion that we have is cobalt. So when we add sodium hydroxide to cobalt, what happens is that like the other 2+ ions, Fe2+ and copper 2+, we react it with 2 hydroxides, and this forms a precipitate. So this time we're forming a blue precipitate from a blue solution. And again, when we add excess sodium hydroxide, there's no visible reaction. And then with manganese, with the manganate 2+ ion, when we add sodium hydroxide, it's reacting with 2 OH- ions, and so forms a pale brown precipitate from a pale pink solution. and the two waters are formed. And again, when we add excess of this sodium hydroxide, we have no visible reaction. So you just need to remember that all of them don't react with excess sodium hydroxide except for the chromium 3+. Now we're going to talk about reactions of metal aqua ions with ammonia. So first let's look at Fe2+. So when we add ammonia, it reacts with two of these ammonia to form the green precipitate. And what is happening is basically the ammonia is acting as a base. So it's taking away two of the hydrogens from two of the water ligands. And so this is how we form this green precipitate and two NH4 plus ions. And so the process is hydrolysis. And when we add excess ammonia, there's no visible reaction. If we look at copper, we have a similar thing. So when we add ammonia to it, we get a hydrolysis reaction where the ammonia is acting as a base, so it's accepting two of the H pluses from two of the water ligands to form two NH4 plus ions. However, what's different is that when we add excess ammonia, the blue precipitate which is formed actually redissolves. And so looking at this equation is going from the original blue solution, so the metal aqua ion. If we add an excess of ammonia, it forms a deep blue solution because ligand substitution actually happens instead of hydrolysis. And so 4 of the ammonias substitute 4 of the waters. And so the waters come out and the complex formed now is charged because the waters and ammonias are neutral compared to the OH minuses, which were not neutral. And so that's why we form a solution. And then for iron 3+, we have when we add ammonia, we have that it acts as a base. So that means a brown precipitate is formed because they've taken away 3 of the H pluses from 3 water ligands to form OH3, and then NH4 plus is formed. And again, when we add excess of ammonia, there's no visible reaction. And then with chromium 3+, the same thing happens. So we have the chromium 3+ and then 3 ammonias, and then we form the precipitate. These colours you probably don't need to know as much because they can actually vary depending on the reaction. But the chromium should be a slight violet green kind of solution, and so it should form a green precipitate. When we add excess ammonia, what happens is the green precipitate then redissolves. So if we're going straight from the metal aqua ion, if we add an excess of ammonia, so if we add 6 ammonia this time instead of 3, ligand substitution happens, and so these ammonia substitute all of the waters, and so we form a 3+ complex, and it's a purple solution, and so the 6 waters come out. And then for cobalt, what happens is that we add some ammonia. So again, like all the 2+ complexes, we form a precipitate, which is neutral because of the ammonia acting as a base. And then when we add excess ammonia, if we add 6 instead of 2, then ligand substitution occurs. So we reform an ion. And so this is also a solution. Now looking at manganate, the manganate 2+ metal aqua ion, if we add ammonia to it, then what happens is the pale pink solution forms a pale brown precipitate, which is uncharged. And also NH4 plus is formed because NH3s have acted as bases. And then when we add an excess of ammonia, there's no visible reaction. So now we're going to look at some questions. For each of the following reactions, write observations and equations for what happens. So for A, addition of ammonia solution dropwise and then in excess to a solution of aluminium nitrate. And so what we do is we remember that aluminium forms 3+ ions. So the metal aqua ion would look like this. And then we're adding some ammonia to it. And remember that ammonia acts as a base, and so hydrolysis occurs. It takes away the H pluses. So that means we need 3 ammonias, and this will form Al H2O3 OH3, and this is a precipitate, and then we have the 3 NH4 pluses which are formed. And the colours for this are that the aluminium is colourless because it's not a transition metal, so it doesn't have a part-filled d orbital. And then the precipitate is white. And then for B, we have the addition of ammonia solution dropwise and then in excess to a solution of copper 2 nitrate. Oh, for A, when we add an excess, nothing else happens. And then for B, to copper 2 nitrate. So first we draw out the metal aqua ion. So we have CuH2O6 with a 2+ charge, and then we're adding ammonia. And first, ammonia acts as a base, so it takes away some H pluses. So we need 2 ammonias, and this will form a precipitate. So CuH2O 4 OH2, and also the 2 ammonium ions. And so we start off with a blue solution, and we end up with a blue precipitate. And when we add an excess, remember that this blue precipitate then redissolves. So what happens is that if we have the blue precipitate here, and we add ammonias to it, what actually happens is that ligand substitution occurs, and the NH3s actually replace the OHs, and so we need 2 ammonias, and this will form CuH2O4 NH3 and this will still have this will regain the 2+ charge. And we also have the 2 waters which have been taken out after the substitution. So we start off with this blue precipitate, and we end up with a deep blue solution. And when I explained this, I looked at the equation going straight from the starting initial blue solution to the deep blue solution. But this is what the equation would be like if you just asked the equation from the blue precipitate. And then for C, the addition of sodium hydroxide solution dropwise and then in excess to a solution of iron 2 sulfate. So again, the first thing we do is write out the metal aqua ion for iron 2 sulfate, which is FeH2O6, 2+. It's a 2+ because it's indicated to us because they've put a 2 for the oxidation number of iron. And then we're adding sodium hydroxide. So when we add sodium hydroxide, hydrolysis occurs. So OH minuses take away H pluses from some of the water ligands to form a precipitate. And so that means that we need 2 OH minus ions because we need to take away 2 H pluses to make the charge neutral. And so this forms Fe H2O4 OH2, and that's neutral. And then we also have 2 waters which are formed. And so the observations for this are that we start off with a green solution because Fe2+ is always green, and then we end up with a green precipitate. And then for the last question, addition of concentrated hydrochloric acid solution dropwise and then in excess to a solution of zinc nitrate. So again for C, nothing else happens when we add an excess, it just stays as the green precipitate. And so we haven't actually looked at zinc nitrate, but we can kind of have a guess as to what happens from how it's a 2+ ion, and we know what happens to 2+ ions when we add sodium carbonate. So we get the zinc metal aqua ion, and we're reacting it with sodium carbonate, so we're adding carbonate ions, and when we add carbonate ions, we form the carbonate, the metal carbonate. So that means we need one carbonate ion, and this forms zinc carbonate and also the 6 waters, because what's happened is that we've gone through ligand substitution. So the carbonate ion has substituted the 6 waters. And we won't need to know the colours of zinc because it's not on the specification. This is just a question where you can kind of guess what happens.